Now, you should know that the kinetic energy of a molecule or an atom is equal to 1/2 mv squared, where that's the average speed of the molecules. Okay? Now, it's also equal to 3/2 kT, where K is Boltzmann's constant and T is temperature. Okay? Now, that's for one atom or one molecule. The kinetic energy for one atom or one molecule. So if you wanted the total energy of all the atoms in there, you would just multiply by what? By the number of atoms, okay? The number of atoms. If it was 1 mole, it'd be Avogadro's number. But we want to multiply by the number of atoms. So the internal energy, which is U, is just equal to the number of atoms or molecules times 1/2 mv squared. Okay? Or number of atoms times 3/2 kT. Okay? So U is internal energy. Thermal energy is how much energy exists because the atoms are moving. You see that? Okay. What? Would that be equal to the total energy? It would be equal to the total energy if the object were sitting still and didn't have any potential energy or kinetic energy. That would be its internal energy, the energy it has because the atoms are moving. Okay? Now, this is usually written U equals 3/2 nkt. Same thing, just that's how you'll see it in books or on formula sheets. Alright? Now, remember NK was replaced in another formula. It started out as little nr. You can also use this with little nr. 3/2 number of moles times r is the same thing as number of molecules times K. K is R over Avogadro's number, and N is N over Avogadro's number. So the relationship there is basically, oh, don't screw up on me now. Alright. Basically, that relationship switches NK and NR, because you can either have the NA under R and it becomes K, or you can have the NA under N and it becomes little n. Avogadro's number, 6.02 times 10 to the 23rd. How many atoms are in one single mole? Okay? Alright. Next page. Oh, wait, what? This is a mass of a single atom. You get the energy of a single atom, and you multiply it by the number of atoms, you have the total energy.
So to get the single mass divided by Avogadro,
Right. If I gave you the molar mass, you would divide by Avogadro's number to get this mass.
That's the number in the periodic table, like right in the element.
Yes. That's the number in the periodic table. Alright. Next page. So what is U? Internal energy, or, from your paper, there was another name for it. Thermal energy. Internal energy or thermal energy is the amount of total kinetic energy if you added up the kinetic energy of every little atom. So it's the sum of all the individual kinetic energies. And these formulas, yes, these are the ideal gas formulas.